Today, we're hunting the silent killer of high-tech manufacturing.
One microscopic hole. That's all it takes to ruin $100,000 of medicine or crash a semiconductor batch. Because in pharma and semiconductor manufacturing, these cleanroom standards aren't suggestions, they're the law.
So where did these powerful filters even come from? Well, the story starts with a bang.
Born in the Manhattan Project to stop radioactive dust, the technology has evolved a lot since then.
The old test used a chemical flagged as a health risk, so the industry pivoted to the safer, cleaner PAO standard. But how do these things actually work? It's not like a kitchen sieve. If it were, viruses would sail right through. Instead, they use three really clever physics principles to trap particles of all sizes.
The smallest particles are like ninjas. They zigzag randomly until they inevitably get caught.
So how do we hunt for those tiny, catastrophic leaks out in the field? We challenge the filter with a safe aerosol, and then a digital photometer, basically a laser, scans for any leaks.
And this is the magic number. If more than 0.01% of that aerosol gets through, the filter fails. Simple as that.
Now, for all you pharma pros, this is key. The US standard, ISO 14644-3, demands we know exactly where it leaks. That's why we have to scan every single inch. The frame, the seals. A leak anywhere means failure.
Okay, so why does all this highly technical testing actually matter to our daily lives?
It matters because this tiny number protects everything from the phone in your pocket to the vaccine in your arm.
You know, a single filter failure doesn't just stop one factory. It can disrupt the entire global economy.
And for the techs on the ground, remember this. If your gear isn't calibrated, your data is just expensive guesswork.
Which leaves us with a critical question. Is your clean room actually clean, or are you just hoping for the best?